Okay, so this is the first exit ticket from week 2. The standard is IOD 501. So if we go to question number 1, it says, based on the information presented in tables 1 and 2, which means you're going to look at both table 1 and table 2, a molecule consisting of 2 elements with electronegativity values of 2.2 and 2.2 will have a percent ionic character. So, percent ionic character is a measure of the ionic nature of a chemical bond. You don't need to know what that is here because it defines it for you. 100% ionic character indicates a purely ionic bond, while 0% ionic character indicates a purely covalent bond. So we need the electronegativity values of 2.2 and 2.2. So if you go here to table 2, I'm going to find the electronegativity value. So this is a key term, this is a key term, and then percent ionic character. So electronegativity of 2.2 is associated with the element hydrogen. And then I'm going to go up here and I see H2. So it's important here when you note that it says 2.2 and 2.2. Nothing else on this list has 2.2, which means that it's an H and an H, which is perfect because right here is H2, and then if you go over to the percent ionic character, it's 0. Alright, number 2. Compared to NaCl, NaF has higher percent ionic character and a bigger electronegativity difference, and then it's going to say lower for both, and then we'll see. So if you go through the table here and you're looking, so I have Na to look at, and then Cl and F to look at. So if I go to Na, that's 0.93, Cl is 3.16, and then F is 3.98. So the difference here between Na and F is going to be bigger because this number is bigger than Cl. So that means that the electronegativity difference is bigger. So that means that I can immediately cross off G and J. Then, if I look here, and I need to find the percent ionic character. So I'm going to go to NaCl, and that's 71, versus NaF is 90. So, NaF has a bigger electronegativity difference, and it has a larger percent ionic character. So that means I can cross off H, and my answer is F. Number 3, according to tables 1 and 2, so those are key terms I'm going to underline, what is the total number of valence electrons possessed by the elements that compose the molecule with 43% ionic character? So I'm going to go to table 1, and I'm going to find 43, and then I'm going to go over and figure out what those elements are. So that means I'm looking at Ag, and I'm looking at O. Now if I find O, it has 6 valence electrons, which you should know already, but that's okay. And if I look at Ag, it's 11, but it says it's got a star. Ag is a transition metal and thus has more complex. So then I'm going to combine them. 11 plus 6, because it says total, so that's a math problem. 11 plus 6, which if you need to set up, which you don't need to, is 17. There you go. There's your answer. Alright, based on tables 1 and 2, which of the following elements has the highest electronegativity and is part of the molecule with the highest percent ionic character? So, the first thing that this says that's important is which of the following. This tripped up a lot of people on the diagnostic. That doesn't mean which one of all of them. It means which one on the table that you can see. So, I'm going to go here. Which of the following elements has the highest electronegativity and is part of a molecule with the highest percent ionic character? So the highest percent ionic character, and it says with the, not which of the following. So this one we're just going to look for highest percent ionic character. I'm going to go to percent ionic character. I'm going to go right here. That means that I'm looking at Na and I'm looking at F. So that means that I can cross off F and G here as my answer choices. Now, between these two, which one has the highest electronegativity? I'm going to find Na, that's at 0.93, and I'm going to find F, which is 3.98. 3.98 is a lot bigger than 0.93, so my answer is F. And finally, number 5. So compared to HF, HCl has A. And then we're looking again at percent ionic character, but this time we're looking at valence electrons. So we need to look at H, we need to look at F, and then we need to look at Cl. So if we go to the percent ionic character for these ones, so we go to HF and HCl. So HF in table 1 is at 55. HCl is at 21. So HCl has a lower percent ionic character, which means we can cross off A and we can cross off B. And then we need to find the number of valence electrons. So we're going to look here at F and Cl. So F has 7 valence electrons because it's a halogen, but you don't need to know that for this. And then chlorine is also a halogen, so it has 7 valence electrons. So if you read your answer choices here, this one, Cl, has fewer valence electrons. We know that's not true because 7 and 7 are the same number.